Maintaining and servicing of a battery charger. Remove the loose dirt and dust resting on the enclosure with a brush or blower. Open the cover and identify the components of the battery charger circuit. Blow out the dirt and dust resting inside the battery charger by a hot air blower or vacuum cleaner. Check the servicing battery charger in for visual inspection and test. Check each and every electrical component and its connection for its soundness. Rectify the items which are not in order. Replace the items which are found defective and also which are missing with the help of the service manual. Reassemble the battery charger and test for its performance. Precautions. Check the level of the electrolyte. If the level is lower than the top surface of the plates, then distilled water should be added. Do not use tap water or well water for topping up. During charge, remove the vent plugs to enable the gas produced inside the cell to escape freely. The room where batteries are to be charged should be well ventilated. A naked flame should not be brought near the battery or cell when it is under charge. The terminal pores should be free from corrosion and they must be covered with petroleum jelly before and after charging. Clean the surface of batteries thoroughly. Dirt and dust will induce leakage of current. Let all connections be tight. Loose connections generate sparks. Necessity of cell groupings. Often an electric circuit requires higher voltage or current that a single cell is not capable of supplying by itself. In such a case, it is necessary to connect a number of cells in series and parallel groups to get the required voltage and current. Series cell connections. Cells are connected in series by connecting the positive terminal of one cell to the negative terminal of the next cell. Suppose 3 D-size flashlight cells are connected in series and each cell has a rating of 1.5 volts and 2 ampere hours, then the voltage in ampere hour rating of this battery would be calculated like this.
Voltage of battery equals voltage per cell multiplied by the number of cells. So if the voltage is 1.5 volt and the number of cells 3, the voltage of the battery will be 4.5 volt. Ampere hour battery rating will be determined like this. In case of a cell with 2 ampere hours, the calculation will be like this. 2 ampere hours into 1 electron volt, which will give us 2 ampere hours. Parallel connection. Cells are connected in parallel by connecting all the positive terminals together and all the negative terminals together as shown here. 4 alkaline cells are connected in parallel and each cell has a rating of 1.5 volt and 8 ampere hour. The voltage and ampere hour rating of this battery would be determined like this. Voltage equals voltage rating of one cell, which is equal to 1.5 volts. Ampere hour battery rating is given as ampere hour rating per cell multiplied by the total number of cells. In this case, it will be 8 ampere hours multiplied by the number of cells, which is 4, and that will give us 32 ampere hours. Series parallel connection. Sometimes the requirements of a piece of equipment may exceed both voltage and ampere hour rating of a single cell. In this case, a series parallel grouping of cells must be used. The number of cells that must be connected in series is calculated first. The number of parallel rows of series connected cells is calculated next. Testing primary cells or batteries. The best method to be used to check a cell or battery is the load test. A substantial drop in cell or battery voltage when normal load is supplied indicates a bad cell or battery.